think, or maybe Lindsay, I can't remember, where we show two different metadata dialects, EML and the content standard for digital geospatial metadata. And these two standards are used by different groups. So within one community, EML, groups like the Long-Term Ecological Research Network and the Knowledge Network for Biocomplexity and GLEON use that, whereas in another community, like the California Digital Library or the USGS metadata catalog or the ORNL DAC use the content standard for digital geospatial metadata. Each one of those sort of dialects, the EML and CSG and GM, covers a bunch of different functional areas, including access, discovery, identification, evaluation, immigration. But they don't cover them in the same ways. So sometimes they have the same content, but they're represented at different levels of granularity. And sometimes one dialect might have a certain set of concepts, but the other dialect doesn't have it. And so there's this mismatch between those two standards, and it causes, you know, more or less a lossy transformation between them. You can convert an EML document into a biological data profile or a CSDGM document and vice versa, but that conversion is oftentimes somewhat lossy going in both directions. So we want to really be able to break these standards down by their concepts and look at each one of the different concepts that comes out in terms of those functional areas and determine whether or not they're useful for a particular recommendation. So what we're going to do here is to build a quality engine, and we've been working on this for the last half a year or so, focusing on 3 different target audiences. The first audience is a set of producers that are building metadata records, oftentimes individual researchers, and they're really interested in metadata quality from the perspective of the record level of what they're actually submitting to a repository. Secondly, we're interested in data repositories and their assessment of metadata at the collection level or across their entire collection of data sets. And then finally, we're interested in the perspective of consumers, individual researchers who are interested in metadata quality at the record level because they want to assess a data set for reuse. So those are 3 different target audiences that we're aiming for through the course of this project. One of the major goals of the project is to automate the checking of this metadata completeness against the recommendations that a community might have outlined. And so we will be basically building a set of tools that allow us to encode recommendations as a set of very formal checks and then run those checks against particular metadata documents to assess the completeness of the metadata against that particular recommendation. In addition, we're interested in metadata and data congruency. That is the correspondence between what is said in the metadata and what exists in the data. So we'll oftentimes find situations where the metadata says one thing. It might say, for example, this data set is a tabular data structure that has 11 variables. And then when you go and look at the data, it's a comma delimited file that actually has 13 variables. And so 2 of those variables are clearly undocumented, and there's some mismatch between the metadata and the data. And those kinds of congruency checks can happen at many different levels, and they reveal a lot of different issues. The hard part about them is that we never know if the metadata is right or the data is right. Like many times it could be that the metadata was incorrect, and it's simply that it wasn't keeping up with the data. At other times, it's the other way around. There's no way to really a priori know which of those 2 it is. So this work on metadata automation or automation of quality checking is a generalization of a bunch of work that was done within the LTR community on a project called the EML Congruency Checker. So Mark Sevilla and Dwayne Costa and Margaret O'Brien and a bunch of other people from the LTR information managers community have been working on a system similar to this, specifically for EML, for a number of years and have it operational. And in this project, what we're hoping to do is to generalize that across multiple dialects so that this new metadata quality engine will work not just with EML, but also with many of the other metadata standards, and to make it work with multiple different languages. Currently, it's relatively difficult to add new types of checks to the LTR congruency checker. With the system that I'll show you in a moment here, we really are looking forward to being able to code checks in multiple different languages. So the idea behind this tool is that we basically create a set of extensible quality checks that they correspond to very atomic, small types of checks that can be rapidly evaluated against a particular subset of the metadata. So they might be something as simple as checking whether or not the title in a metadata document is sufficiently descriptive. There are obviously different rubrics for that. One would be that the title exists at all. So if the title exists, it might pass. Another might be that the title is of a sufficient length. Like if the title isn't at least 7 words long, it's probably unlikely to be sufficiently descriptive. We've frequently found in the corpus of metadata records that we have checked that people will oftentimes use a file name for a title. And a file name like, lakedata.csv doesn't really go very far in providing the level of description that somebody wants for data discovery. So we can get increasingly sophisticated about the types of checks that we encode, but we can also start simply and just check simple things like existence and length of metadata fields. Another type of check that one might be interested in is whether or not attribute names are unique. So this would be going through and looking at all the variables within a data set and deciding whether or not they've provided unique attribute names for each. Super useful, oftentimes something that people don't manage to do, and simply pointing it out to people that they have 3 columns that have the same name may be very valid or very useful to them in the process of authoring metadata and data. So like these, other types of checks continue down this list. So all the ones marked with an M, M1, M2, M3, M4 are all checks that specifically depend upon metadata. And the ones that are C1 and C2, those are congruency checks, where something in the metadata is being checked against something in the data. So for example, the one labeled C1 is looking at the checksum that's in the metadata and making sure that the checksum actually matches the data. That is, it calculates a checksum for the data and checks to see that they are in fact the same, or that all the data links within a metadata document are actually correct in returning data. So these types of metadata and data checks together are congruency checks. And then the third types of checks are data-only checks, where we're looking at the data, looking for some aspect of quality. For example, looking for duplicated data rows, or it returns maybe a count of the data rows that are strictly duplicates of one another. So those 3 types of checks, metadata, congruency, and data checks, are all intended to be enabled by this quality engine that we're putting together. Each one of these checks, as I mentioned, can be written in Java, R, Python, or potentially in the future other languages. We've written the quality engine such that there's basically a relatively simple adapter path, an adapter class that allows for new language support to be added. I think right now we're supporting Java, R, Python, and JavaScript, although we've been focusing on R and Python for the implementation of the checks that we have been writing for our first sort of suite. Each one of the checks within this set can be categorized. In our case, we're trying to categorize them by function, for example, discovery or citation or data interpretation, so that somebody can get a sense for how many of the different checks a given document passes, using that particular functional area. And then again, checks can operate across dialects. So we can check, for example, that within an EML document or a CSDGM document, that all of the attribute names in that document are unique. And so the idea here is that we can start producing recommendations that are no longer quite as strongly tied to particular dialects, and instead the recommendations have to do with the concepts, and we can find out whether, regardless of whether something's represented in EML or ISO 19139, either way, the metadata that's of interest is provided or not. So once we have a set of those types of checks, each one of these checks is sort of like a unit test for a particular piece of functionality, and they can be assembled into community recommendations. So a recommendation is a group of quality checks, like the ones from that list before, It can be created by any community and can include standard or custom checks that access both metadata and data. And so down below, you'll see that I put together 3 sort of lists: the LTR best practices list, the attribute convention for data discovery, and the Arctic Data Center recommendation. And you can see that each one of these would be basically a list of checks that represents that recommendation, and that's what would be checked in order to understand whether somebody is compliant with or passing a particular recommendation. And this allows the engine a degree of flexibility in the sense that not only can users of the engine extend the set of checks that are available, they can also group those checks into recommendations and see which of those recommendations are being passed by different metadata corpuses. So here's an example of a check, or 2 examples of checks. So a little bit of code. In the first bullet there, we have an example in the R world of a check that checks whether or not any attribute names within a metadata document have been duplicated. And so you can see a check can be very simple. It can be just a one-liner where you, in this case, use the R code for determining whether or not a vector of attribute names has any duplicates or not. Of course, most checks are not going to be just one-liners. I did this just to sort of illustrate that the check engine is relatively straightforward to utilize, and there's a lot of sensible defaults. So if a check basically returns true, that check passes, and as a result, you end up with a relatively simple check to write. In reality, most of the time, you're going to have a much more complex check that you want to write. You're going to want to make sure that you've checked a number of different error conditions and that you've handled things well across the metadata check. And so generally they're going to be longer functions, like the one that's shown in the Python example there for the presence of the publication date. So in this case, we're defining a function called call. It basically looks at the pub date variable that's been passed into it, and that checks the length of that variable. And based on that length of the variable, it makes some decisions about what to return as the status of the check. So each check can return a status of success or failure, and when it does that, that success or failure can be accompanied by some messages that help the user to interpret what might have gone wrong. And here you can see that in the case of the pub date length being less than 4, the message is that the publication date is less than 4 characters long, whereas if it weren't, then in fact it would say it's the publication date length of, in this case, %s would be 4, it's valid. And so you can return a bunch of information back to the user under different conditions, and that's how this check language works. It's consistent between R and Python and the other languages we support. And they always have this message and the status flags. So obviously that kind of code is necessary at the engine level, but it's not what users want to see. And so I have a few screenshots here where we go through and kind of illustrate the types of functionality that we're putting together. So the check service that we ran uses those check codes within R and Python and other environments and can execute them against particular data sets. So in this case, I'm showing you a data set from the Arctic Data Center, which is one of the repositories that we operate at UCSB, at NCEAS. And this Arctic Data Center has a large number of data sets that have been contributed by investigators throughout the Arctic sciences community. Now, those investigators need to provide high quality metadata in order to satisfy NSF requirements for submitting their data that's associated with their research that's funded through NSF. And so at the Arctic Data Center, we're excited about this quality engine because it's going to allow us to provide really consistent and standardized reports back to the investigators that are submitting information so that they can help improve the metadata as it's coming in, and we can point out specific areas where there's work that's needed. So in this case, this data set consists of a metadata document, which you can see basically on this line here, and then 2 data files, in this case a PDF README file and an Excel file. And these data sets and metadata, these data files and metadata files are accessible through the Data One API, because the Arctic Data Center is a nascent member of Data One. And so the check engine can go and retrieve those metadata and data documents from the Arctic Data Center and use them in running the quality report. So right here, if the user clicks on the quality report button, it basically goes through and runs a recommendation, in this case the Arctic Data Center suite, and it checks that suite against a large number of metadata and data quality checks. We currently are running 23 checks in the suite that we in the recommendation that we put together for the Arctic Data Center. And if you look at these, in this case, when this suite was run against this particular data set, of the 23 checks, 12 of them passed. There were 3 warnings, 3 failures, and 5 informational checks. And so that, that's a very useful thing for the user to just get a summary of this. They can also look at the way in which these, each one of these checks relates to different functional areas. So if you look at the identification and citation sort of use case area, 58% of the checks have been passed. For data discovery and searchability, 80% have been completed. For ancillary metadata information, 0% have been completed, and 67% of the metadata concepts associated with data interpretation have been completed. So we're still in the process of going through and deciding what the categories should be within this area, the functional use areas, as well as what the specific set of checks should be for the Arctic Data Center. But over the next several weeks to a month, we plan on rolling this out to the Arctic Data Center as part of our production services, and we'll have finished up that assessment. So I'm going to run through a couple of the types of checks that are in each of these different categories, but these checks will be modified to some degree as we evaluate them and their utility. So first, if you look at the checks that were passed, there are a number of checks that pass, and when that happens, you'll see that each one of the checks is listed and it's given a little check mark showing that it passed. And in this case, we're checking, for example, that the title was present, and that's a very simple check, but nevertheless useful. We're also checking to make sure that the creator or the originator of the data set is present, so that they filled out those basic metadata fields for title, creator, and contact and identifier. And then finally, we're checking to make sure that the proper license wording was found, that somebody has actually provided the specific types of licenses that are allowed at the Arctic Data Center. And so those kinds of checks are all useful for understanding whether or not something is identifiable and citable. And so all of these checks you can see are categorized in the identification category. They're all required and they're all successful. So those are a great set of checks and things that are really useful. We'll be expanding that set for the Arctic Data Center over time. And then the second sort of 2 sections are the warnings and the failures. So warnings are basically checks that, instead of being required, are optional. So over on the right-hand side, you can see that the 3 warning checks have been marked as optional, and they failed in the sense that the metadata document didn't pass this check. But because it's optional, it's just a warning. And so what the recommendation author is saying is that something that should be present in this metadata document is not present, but it's not going to, it shouldn't really stop the data set or the metadata record from being useful. So in this case, for example, there's a sampling description wasn't provided, and the study extent description wasn't provided in the methods section. And both of those failed because the methods element itself wasn't presented. So in this case, we're missing some critical information from the metadata document, but it's not enough to really trigger a complete failure of the check. Whereas the 3 checks within the next section really are considered things that should be required, and because they're not present, they really should be considered as something that causes this whole recommendation to not be passed. So in this case, the abstract was only 74 words, and somebody was expecting a longer and more complete abstract. In the dataset title count was only 5, or no award numbers were present. So in the case of the Arctic Data Center, we must know exactly which award a particular dataset came from. And so those concepts or things that need to be corrected in order for this data set to pass.
Hey, Matt.
Yeah, go ahead.
This is Ted. What's the relationship between these? Let's see, for the title, for instance, in the last slide, you said the length was either 1 or 2. And here it turns out that, yeah, what are those links there?
Yeah, this is actually, we're working through some of this language a bit and trying to make it more consistent. So what this means is that in this slide, this is really checking whether title is present or not, or absent. And it turns out that title is a repeatable field. And so it's possible to have more than one title in a document. And so this is talking about the number of titles. So this is saying that there was actually one title in this document, one and only one, one instead of 3. Whereas this other field here is checking the length of the title, and it's saying that it had 5 words in it. Whereas
yeah, okay, thanks.
Yeah, so that's the difference there. We recognize some of these basically communication problems, and we're working through those now, trying to clean up the language a bit to make it a little more understandable. But I think that's all I had to say about the warnings and the failure modes and their representations. The last category is the informational checks. And so these are checks that aren't technically going to be passed or failed. They're really checks that are informational or are meant to provide additional utility in interpreting and understanding the data set and the metadata. And so, for example, there's an informational check here saying that the coverage elements for geographic coverage is present at the data set level, but it's not present at the entity or attribute levels, which is, potentially useful for some people. The other thing that you can do in this informational check is use the information in the data and the metadata to basically drive graphs. Something's weird going on there. Can you still see my screen?
Yes.
Yes.
Yeah, okay, great. For some reason, everything got inverted for me for a second. Yeah, so you can build graphs that represent either a data summary, or it might be the head and the tail of the data set, or maybe you calculate some statistics like outliers, or maybe you look at the distribution of the data and plot, so that somebody can evaluate whether data are normally distributed or otherwise meet some criteria that's important to them. So these informational checks can really exploit the full power of what's available within languages like R and other languages, and produce not just textual information back to the user, but also graphs and plots and other things that are of use. Something's going on with my presentation here. For some reason, it's not letting me advance. Okay, so I wanted to briefly sort of look at the architecture of the metadata quality engine for people that might have interest in using this. This quality engine that we've put together is a open source and publicly accessible quality engine, and we'd love contributions to it. As I mentioned before, it allows checks to be written in R, Python, Java, and potentially other languages. It accesses data and metadata from within the Data One Federation of data repositories, but that could also be extended. And it provides a REST API for client access. And so the idea here is that we basically have encoded the information, or we encoded most of the functionality of the metadata quality engine in a library that's written in Java that involves a run controller and these check managers and dispatchers that interact with R, Python, and Java. So in the middle of this diagram, you can see that the core of the implementation is all a library that can be embedded in multiple different applications. We've then exposed that library through an API And that API in turn is exposed through a REST service to the outer world. And so the metadata quality engine REST service is something that can be deployed in multiple different environments. In our case, we're deploying it within the context of, for example, our member node repositories within Data One and at the Data One federation level overall. But other people could deploy this engine behind their system. The key is that you need a mechanism for passing data and metadata into the engine, and that's done through this Data One API access down here at the bottom for access to both coordinating nodes and member nodes within Data One. That could, of course, be swapped out as well for other things. So right now, we're implementing this library and deploying it for people to use, and if you're a member of the Data One Federation within the next 6 months or so, we expect this service to be available to everybody that's already participating there. But other individuals that are interested could utilize portions of this and contribute to the open source quality engine as well. So if anybody has interest, please feel free to contact us, and we'd be happy to talk through the different parts of the system with you.
Hey, Matt.
Uh-huh.
This is Ted again. The metadata quality engine, the inner workings of it are written in Java, is that right?
Yeah, so the metadata quality engine itself is a library within Java. And then, like I said, the checks are written in multiple languages. So
right. Okay.
My slides are still having trouble advancing for some reason.
I think this is a go-to thing all of a sudden, because it happened to me last week during a talk, and all of a sudden PowerPoint just stopped working.
Yeah, well, I'm just going to drop out of the full screen mode for a minute and leave it here. So there's a few issues that I wanted to review that we're still talking about and trying to figure out how to handle. So one of them is that we need a mechanism to summarize results that is useful to the different that we're targeting. So in particular, we're interested in being able to express to somebody the percentage of successful checks that their document passes without necessarily discouraging them. So if somebody has a metadata document and it's a big complicated recommendation and their document passes 7% of the checks, that might be more discouraging than encouraging. So we're looking at ways to be constructive about this feedback to submitters. One of the ways to do that is to break the checks down into smaller groups and have these subcategories like identification and interpretation. So somebody might be doing well in the citation area. They might, for example, be providing 90% or 100% of the information they need to properly cite their data set. And they might be doing well in, say, the data discovery area, in the sense that they might be providing all the information they need for data discovery, the temporal and spatial coverage and things like that, whereas they might not have fully provided all of the entity and attribute information for data set reuse or interpretation. And so we want to be able to break it down in ways that allow people to constructively and gradually improve their metadata records. One of the other things we've been looking at is whether or not it makes sense to express percentages as the percent of successful checks, meaning, for example, that you have 37% of the recommendation is passed, or to compare it against other data sets in a collection. So, for example, somebody might only check, and they might only succeed on 37% of the checks in a recommendation, but that metadata record might be better than 89% of the other data packages in that collection, which gives you a sense that although this has a lot of room for improvement, it also is better than most things that are out there already. And so that gives you a different kind of sense of where things stand. So when we have a tremendous amount of variability in the quality of metadata records, these different ways of summarizing results might prove useful in different contexts. And we're thinking about how to best display that. One way we're thinking about doing that is to display multiple recommendations as a set of badges. So on the landing page for a data set, we're thinking about looking at and saying there's a citation badge and a discovery badge and an interpretation badge. And as each one of those gets sort of earned because of the quality of the metadata, that badge lights up and shows it as basically, a feature of that data set that might be of interest. And so we're trying to make it into something that somebody strives to achieve, as opposed to looks at as a negative that they haven't achieved it. It's sort of, I guess, they're a little bit of trying to present things in the best light. And then the last thing I sort of wanted to go over, boy, my PowerPoint is not too happy today. Or sort of the next, so the last thing I wanted to go over are the next steps for this whole system. So over the next couple of months, we're planning on deploying this system for 2 of our repositories that we operate at UCSB, so the Arctic Data Center and the KNB Data Repository. And each of those will have a different set of recommendations that they're looking for. So the Arctic Data Center has a set of recommendations that are specific to requirements within the Arctic program in GEO, and the KNB repository, as kind of a more caveat emptor repository, will have a lighter set of recommendations, but probably a similar set of checks. And so there'll be fewer things required in the KNB than in the Arctic Data Center, but they'll be presenting similar types of information. And then in addition, we're planning on deploying this as a Data One service for member repositories. To do that, we have to really diversify enrich the set of checks to make sure that they work really across a much larger set of metadata standards. Data One, as a federation of metadata repositories, supports a large number of different metadata dialects. So I think about 13 of them right now are in common use. And so we need to diversify our checks to really make it applicable across that larger suite of repositories within Data One, and we'll plan to do that. A second major area of emphasis for us is once we get these checks working at the individual record level so that you can display results for one record, we plan on then starting to index and populate results, aggregate results across whole collections of records. So the idea is that we would run the check code for a particular recommendation on a whole collection of metadata, for example, for all the records from a data repository or all the records from a researcher, and then be able to summarize the results of those records for that at that level of granularity. So we might be able to say that for a particular person, their metadata records on average pass a particular recommendation 80% of the time, but another area like interpretation, they might only on average pass 30% of the time, or some other sort of aggregate result across the collection. And so we're looking at this at 4 different levels of aggregation: the data repository, the researcher, particular projects, and funders or funder programs. And so that aggregation feature is something that will be rolled out over the next year and will become part of the suite as well. Okay, so that's it for me. I have this couple of links here on this page. There's a GitHub repository for the open source version of the system. My slides are posted up on Figshare at that URL. And I wanted to acknowledge and thank the National Science Foundation for their support for this award, as well as my colleagues Ted, Bryce, Peter, and Ben, and Lindsay and Sean for all their work on this project. It's been a great collaboration. So thanks very much. Any questions?
Thanks, Matt. Appreciate your time and effort putting that together to share with us. We definitely have a couple of minutes for questions. If anyone would like to ask one, now's your chance.
Hey, Matt, this is Anna.
Hi, Anna.
I was curious about your data congruency checks. I saw that you showed 2 of them. Are there more congruency checks?
Yeah, there can be.
Can you talk about them a little bit more?
Sure. For all of the checks, there can basically be an unlimited number of checks of any type. I gave this list as kind of an example, what would fit on a slide. But in fact, there typically would be probably at least tens or dozens and maybe even hundreds of checks in any one of these categories, because many of the checks are at a very fine grained, and there's hundreds of fields within metadata documents to be checked. And so yeah, there can be easily many different congruency checks as well as metadata checks, and of course as many data checks as you can imagine for evaluating the quality and effectiveness of a data set. So
do you have other examples of what kind of data metadata congruency checks you have?
Yeah, we have a large number in mind. So we've put together a spreadsheet, which I don't have the URL for that here. The LTR community had developed a large number of checks in their congruency checker. And that we started with that, and then we've been expanding from there. So we probably have, I think, on the order of 50 or 60 checks outlined right now, not all of which have been implemented. And we plan on continuing down that line. I'd be happy to share that list with people, and we could brainstorm about what other checks would be useful. And of course, anybody can write their own checks. Our intention is that over time we would allow for people to propose checks that we might be running as part of suites within our data systems. But it's really up to the administrator of a system what gets run, because it's important from a security perspective that all the check code that's being run is vetted well. So does that answer your question, Anna?
Kind of. I'd be interested in seeing that spreadsheet.
Yeah, I'm happy to share it with you.
Thanks.
Hi, this is Bob Simons. You have tests. I'm not sure if there's a distinction between tests for the whole data set versus tests for each individual, what I think you call attribute, or I would call column or variable. So I'm wondering, like for valid units, is that tested for each of the attributes, and then do the percent of checks passed, how does that deal with the variable number of columns in a given data set?
Yeah, so those are tricky issues, especially when it comes to summarizing and how to basically represent meaningful statistics. The way we've left this at this point is that each check defines its own. We basically leave it up to the check writer to decide what the level of granularity should be and what's useful. I think you're absolutely right that it would be very easy to write a set of checks that, based on the number of attributes, would then make it hard to interpret the overall summary statistics. Something like valid units in this case, we have written this in such a way that people can ask for all of the metadata associated with a particular concept, like ask for all the metadata providing column or attribute definitions, and then the check itself can go through and check that they're all correct. In this case, our valid units check makes sure that all of the columns of the data set have appropriate units, and it passes back an error. It can pass back multiple errors for each of the different attributes within a data set. So we can pass back a list of problems instead of just a single problem from a check. And that list of problems describes all the things that might need to be fixed, but the check might still only pass or not pass based on whether or not all of the units are properly assigned. So it's up to the check writer how it's done, and I totally agree it can be confusing, and that kind of fine tuning is some of the work we're doing now. We have this engine running and functional. The engineering team at NCS has done a fantastic job of putting it together, and what we're really doing now is going through these checks and trying to really fine tune them in a way that makes them understandable by end users, and that takes a bit of time. Good, Bob?
Good, thanks.
Matt, since we just had Anna and Bob ask questions, I can't resist making a comment to Anna. The congruency idea Matt mentioned that it started with LTER, and they did, he mentioned Mark and Margaret and a few other people did some nice stuff there. And EML has this concept of a data package, which is sort of data plus metadata. And of course, a lot of the data sets that they're dealing with are, a small number of files or a single zip file or something like that. And so this congruency thing worked out really well there. In things like NOAA and NASA and maybe some other situations, I think the congruency tests would be very interesting in situations where people are running various services. So if you had an ISO metadata record and it had in it links to something like a WMS or a WCS, or in the case of things like AirDAP, an OpenDAP link, you could hit an OpenDAP, say an OpenDAP metadata response like a DMR or something like that, and you could compare the metadata that was created by the service from the data set directly to the metadata that you have in the repository somewhere. And of course, in the WCS or OpenDAP case, you might be able to actually retrieve data, if it made sense. And you could also do things like describe coverage requests and responses in OGC land. So in terms of, Matt and I have been, or I learned about this congruency stuff a while ago from Matt, and I've been thinking about how it might work in a NOAA or a NASA context. And I think that as NOAA particularly and NASA both actually build out their service access metadata, it could be a very interesting idea to build in.
Thanks. That is helpful. Especially in regards to the access and how things are documented.
Yeah.
All right. Well, thank you, Matt.
Is there still time for another question?
Sure, go for it.
Okay, this is Gopeng, and I have a question for Matt. Great presentation, by the way. At the end of it, you did indicate the future plans for indexing collections, and you have mentioned repository, research project, and founder. And I'm wondering whether you have run into or potentially run into a situation that the checkers are built based on, let's say, EML or data one, and that might be sort of in favor certain project and bias towards other project. If you do, how you think about addressing that?
So I'm not sure I fully understand your question.
Okay, you have talked about index data collections.
Uh-huh.
So you have performance for certain, let's say, for example, project. And because your checkers are built on current requirement or existing requirement, let's say data one requires certain things, and ecological EML requires certain things. And I'm just kind of wondering whether you have run into a situation that the performance as the completeness of the checkers might be biased towards certain projects compared to others, because different projects may have a different requirement.
This is absolutely the case, and I mean, I think in many ways this is the whole point of the project, is to be able to do these comparisons across collections and have people understand where their collection fits for particular uses. I think if a community has already decided upon a particular recommendation, then it's really useful to be able to tell that community, that whether or not a set of metadata records, really follows that recommendation or not. But what's also useful is, I think, an area that Ted has explored more thoroughly, which is to look at, say, a community that might be interested in following a particular recommendation, but their community has already adopted another one. And then the question they might ask is, does the metadata that I have today say in my EML-based system, does that provide sufficient information to be able to pass the recommendations that are needed by another community? So maybe people within the EML world want to provide information to, you know, to NOAA or to an agency that requires a different metadata standard. Or maybe they want to use the catalog services for the web recommendation, in which case, you know, they want to know whether or not the metadata content that they have in their corpus is useful for and adequate to cover these other recommendations. And these sorts of tools can help with that as well. And so I think when you talk about bias, but what I really think, I think of that a little differently. It's not so much about bias as it is that the tool will allow us to expose the strengths and the weaknesses of each of the different dialects, and where they're useful and where they'll need help with other things.
Yeah, I like that philosophy rather than biased. Yes. And the second part will be if there's a way to address the difference in the type of data. What I mean by, you know, whether it's a research data or operational data, or let's see, high utility data, because they may have different requirement in terms of quality.
Yeah, I mean, certainly the engine can be configured in such a way that you can run different recommendations against different suites of data and metadata. And so you could have a customized set of checks for each of your different categories, and that would be great. I think, as Ted pointed out, there are definitely some challenges with the engine as we've currently written it for certain types of operational data that are really large scale. You know, right now the engine's pretty naive. It transfers the data to a local cache and then executes the checks against that data. And for larger data that comes from, say, a large field campaign or satellite sensor, you're definitely going to run in trouble with that. And I've been really interested lately. Bob Simons has been communicating with me and some other folks in LTR about their work on ERDAP and some of these other services that allow you to run certain types of queries and execute information, execute queries at the source. And that's a real interesting thing to me, in thinking about how you can connect some of these services that run to our quality engine. Instead of trying to transfer the data to the quality engine, instead it would be really interesting to see if we could transfer or embed this quality engine in a tool like ERDAP that has access to data that's remote, and then the engine just kicks off something on a remote service. This is very similar to what's done in the IRODS system with their rule engine through IRODS. So I think there's a lot of room for improvement and being less naive in the data execution part of this. But
sounds good. Thanks a lot.
All right, guys, I'm going to cut off the discussion there. We've got a couple of business points to go over before we leave. I'm going to just try and grab presentation back. Can you all see the documentation cluster minutes?
Yep. Great.
So we have 3 things to go over. The first is I'd like to wish happy birthday to Rich Signell. And then we need to start thinking about documentation sessions for winter 2017. There is a page up on the wiki with documentation sessions winter 2017 as the title. There are a couple of proposals up already. Please do add in your own. We need to generate a list here. We've got a deadline coming up, so I would like it if this part of the conversation could continue offline. But once again, please do add in your own or edit others. And then finally, the collaboration area also needs to have a poster so that that people outside of our collaboration area can know what the heck we do. So I have included in the minutes page for today a link to the ECIP Commons. There you're going to find a bunch of posters, but if you look for these ones that say Collaboration Area Showcase, or you know, one like this from the Semantic Web, you know, I think we can do better. So you know, that's a low bar.
It's full of meaning.
There's a lot of meaning there. That's right. And then here's one from the cluster, the disaster life cycle cluster. So anyway, there are a couple of examples on this page to see what other people have done. We need somebody to go ahead and take on that task so that we can put together a poster meeting and let everybody know what we've been doing. So we are out of time for today, but please do the next meeting. I'm going to go ahead and bump that up from the 28th to the 21st of November so that we all have an opportunity to not have stomachs full of Thanksgiving dinner while we're meeting. Rebecca Kosetka is going to be giving a talk, and hopefully we can go ahead and get our session ideas submitted and get some traction on our poster. And thank you all for joining us today, and I hope you have a great week.
Thanks.
Thank you.
Bye, guys.
Once again,
Thanks.
thanks to Matt Jones.